So let's look at some of the problems that require us to use all of the rules that we have learned. I put a more difficult problem up here, and it's just representative of what could happen. Here's an equation with a number of the unknown quantities which we're supposed to find out. We see we have an x squared there, and an x squared there, and an x there, and an x there. So we have to use our rules to unwind this and get to the actual solution to this equation. An equation in one unknown that's not an identity will have one solution. So the first thing you have to do is, according to our mnemonic, pretty please, my dear Aunt Sally, we need to deal with the parentheses first, which we see we have right here. So we have to deal with removing this parentheses. Now, this parentheses is preceded by a negative sign, which you can think of it as multiplying everything in that parentheses by a -1. So that's what we're going to do. We're going to multiply everything in here by -1. Now, by far, the biggest mistake that's made by students is when there's a negative in front of a parentheses, because we get a little lazy and we pay attention to the negative as for the first term, but then when the other terms come, we lose it. So I'm going to just copy down this 18x because I'm doing nothing with it. Now I'm multiplying -1 times 1. That's going to be -1. Then -1 times -3x. A negative times a negative is a positive. Then a negative times a negative is a positive. X squared equals this side 22 plus x squared. Now if we analyze what we have, we see that we have x's on this side and we have an x squared on that side. We have an x squared on this side. Let's clean this up. Now sometimes students think that the way you get things together is by adding the opposite, but I want you to notice in this equation that here's where the balance is. Everything over here is on the same side of the balance. So we don't get rid of this positive 3x by subtracting it, because these are not on opposite sides of the equal mark. We just, like I tell the kids, tidy up your room, put all your shoes together, put all your shirts together. So we need to put the x's together. So there's 18 of these x's and 3 of these x's, so that's 21 x's altogether. And then we have an x squared, a -1, and an x squared equal 22 plus x squared. Now we see we have no cleaning up to do on this side. Well, we could put them in different order. No cleaning up to do on this side, but we need to get things together. So what we do to one side, we have to do to the other. So let's deal with the x squared. We have an x squared on both sides, so let's say if we subtract an x squared from this side, we have to subtract an x squared from this side, keeping our balance the same. Let's see what happens. We get 21x minus 1, these guys kill each other off, equals 22. Now we're trying to get that x by itself. Now just like on the easier equations, this 21 is attached to him by multiplying, so we don't want to deal with that first. The first thing we're going to attack is this -1. Now this -1 is on the left side of the equation. To get rid of it, we will add a 1 to this side, and if we do that to this side, we have to add a 1 to this side, because those things are equal. We're really adding to the opposite sides of the balance. When we do that, we'll draw a line here, and we're going to add the -1 and the +1, kill each other off, and we have 21x equals 23. Now we're almost home. In order to get the x, we have to get rid of this 21. What is the 21 doing to the x? It's multiplying it. So to get rid of it, we're going to divide this side of the equation by 21, divide this side of the equation by 21, and we're going to find out that x is 23 21st, or 1 2 21st, but you can leave it in this improper fraction form. Now that you're in algebra, we don't care about whether the numerator is bigger than the denominator. All right, I hope you followed that problem. I'm going to work a couple couple more that are a little bit on the more difficult side. I hope that this will help you to see how to handle and especially pay attention to what happens when you multiply a parentheses by a negative. Have fun. Bye. Let's look at another more difficult problem. It's got parentheses within parentheses. Now you see right here I have not a parentheses. I could have drawn parentheses here, but I used brackets, and a lot of times you'll see brackets are used to help you not be confused as to which parentheses goes with which parentheses, but that means the same thing as another parentheses. So when you have a parentheses within a parentheses, you start and work from the inside out. So what we want to do here is we want to start working with this. Let's see if I can't get a pencil here. Let's start with this parentheses and just focus on removing this parentheses. Now again, I've chosen to put a minus in front here because this is where a lot of mistakes were made. If it were a plus, you would just, if this had been a plus, you would just say x plus 2x plus 8. But with this negative, it makes everything a little more complicated. So we have to think of a -1 being right here that has to multiply every term that lives inside the quantity. So I'm going to just copy down. I get 7x minus, and now I'm going to replace this bracket with a parentheses because it'll be the only one left. X. Now -1 times 2 is -2, and that was an x. -2x. Negative times positive is -8. Close parentheses. Now see, the difference between this line and this line is that I've gotten rid of that inside parentheses, and look how the signs changed. When you multiply by a negative, every sign in the parentheses changes. So now we have 3x minus 2. Now we have another parentheses to deal with, and of course I made it have a negative here as well, so we'll have to put a -1 here. So this would be 7x. Negative times positive is -1x. You don't have to put down the 1. A negative times a negative is a positive. 2x. Negative times negative is a positive 8 equals 3x minus 2. Now the challenge here is to clean up both sides of the equation. Don't try to subtract off or anything like that. Clean up your work when you have a big mess like this. Let's clean it up. This side doesn't need any cleaning because there's only an x term and a constant term, so that'll stay the same. But this side, we have to gather the things that are alike. So we've got 7x's minus 1 ununderstood 1x. Now we're down to 6x plus 2. That makes 8x plus 8. Now we have an equation with variables in both members. We have an x on this side and an x on this side. Now here, different teachers have different attitudes toward this. Some teachers always like to get the x on the left. Some teachers like to get the x on the side that has the most already. But in this case, the left does have more x's than others. But what you have to do is always follow the rules. We need to get the x's on this side together with the x's on this side, and here's our balance. So we have to make sure what we do to one side, we have to do the other. So I really like this 3x to go away. So how do I get that? It's being added to this side, so I subtract 3x. I subtract 3x. And I usually draw a line because it helps me keep straight what I'm doing. 8x's minus 3x is 5x plus 8. These kill each other off as planned, equals -2. Now we need to get this x by itself. So how will we get rid of this plus 8 from this side of the equation? We would subtract 8 from this side, subtract 8 from this side. I'm going to draw a line again. These 8's kill each other off. We get 5x equals -10. How do I get rid of this 5? I divide by 5, divide by 5, and I'm about to run out of space. X is equal to -2. And if we plug that -2 back in, everywhere there's an x, we would see that it makes a true statement. That would be the way we would check to make sure that we actually have the right answer, because there's only one x that would make this original equation happy, and that happens to be -2. Hope you followed this. You can play it again if you need to go over it one more time. Thanks. They say the third time's the charm, so let's work a third problem. I don't have it typed up, but let's work a third problem just in case. All right, now here we've got a couple of parentheses in the equation, 2 on this side and 2 on this side. So, and this will give us a chance to multiply by a plus. So let's take a different color here and just go through and let's see if we can't remove all these parentheses. They're all of the same importance. So right here, this 3x plus 6 has an understood 1 in front of it, and if I multiply everybody in here by 1, I'll just get the same thing, 3x plus 6. Now when I come to this minus, this is multiplying everybody by -1, and remember the negatives change the sign, so this would be minus 2x plus 2, because a negative times a negative is a positive. This is 17 minus 2x, because this is an understood 1 right here, plus, and this time we have another plus 1 here, so this is going to be 2x minus 13. Now we have a big mess here. Clean up your room. Here's your balance. Clean it up. Don't try to work on it with all that stuff everywhere. It'd be like moving with all your stuff on your bed. You want to get things organized. So I'm going to clean up this side. Is there anything that can go together? Just treat this as an expression that you had to clean up. Well, I see there's 3x's minus 2x's. That's 1x. 6 plus 2 is 8. When I was young, I used to put a line under everything as I gathered it up so I didn't accidentally leave somebody out. See, I'd say I took care of them, and now I took care of them. When there's nobody that's not underlined, I know I have everything gathered together here. You might do something like that yourself. All this mess reduces down to x plus 8 equals, on this side we have this constant number, 17, and I see another one right here, minus 13. That's 4. Oh, look, these x's are so neat they kill each other off. So this problem sort of falls apart as we do it. Now we want to get the x by itself. So how will we do that? The 8 is being added to it, so to get rid of it we will subtract 8 from that side, subtract 8 from that side, and this problem wasn't so hard after all. It turns out to be x is equal to -4. Now, if we plug that -4 back in here, every place, we would find that it would make a true statement. My conscience is getting to me. Maybe I need to address what would happen if we had an identity. So let's see if I can select all on this and delete this and say, what if somebody gave you an equation like, let me make this up. It could be an identity or it could be a lie. What if I said 2x plus 4 equals 2 times x minus 3? And you just merrily started to work this problem. It's simple enough, but it could be more complicated. But as you unwind it, you say, well, I can't do anything to this side. But now I end up with 2 times x, 2x minus 6. Get the x's together, and here's where strangeness begins. Strangeness, you say, I've got to get the x's together, subtract 2x off this side, subtract 2x off this side. They kill each other off here, and they kill each other off here, and we get 4 is equal to -6. What does that mean? That means that this thing right here, this equation up here, can never be true, because it will only be true if 4 is equal to -6, which can't be. So if you bump into something like this where the x's completely drop out, you write down, and it turns out to be a false statement that will never be true, you write down no solution to this. Got that? Now we come to the other hard part. You can see why we sort of sometimes leave this out. We get so happy that kids can solve equations that actually work. To give them one that doesn't work is kind of confusing. What if we had this? This is a completely different problem. What if I had 2x plus 4 equals 2 times x plus 2, and you merrily worked it. You can see this is, I'm setting you up for a fall again. 2x plus 4 equals 2x plus 4. Subtract the 2x, subtract the 2x, kill, we get 4 equals 4. Well, this is true when 4 is equal to 4. Is 4 equal to 4? Always. If we really were enthusiastic, we could subtract 4 from both sides and get 0 equals 0. Always. So that means that this thing is an identity, meaning that what we gave you on the left was really worth identically to what was on the right. It was just in disguise. So when this happens and you do the problem and it turns out to be something that's always true, you say, well, it's always true. It doesn't matter what x you put in there. So this has an infinite solution. Infinite solution, which means that you can't go wrong. You could say x could be 1. See, then that would be 2 plus 4, 6 would equal 6, true. X could equal to 2. 8 would equal to 8. If you put in a 5 in there, 10, 14 equals 14. See, anything you put in here would work. So we say that has an infinite solution. So if you work a problem and to your surprise, the x's drop out, ask yourself, is what's left true or false? If it's true, like 4 equals 4, then you have an infinite solution. If it's false, like 4 equals 3, then you have an impossible situation and there's no solution. We will study this some more in Algebra 2, but for now, you try to assimilate it if you can. Welcome to algebra. It's a little tricky. Bye.